All right, so I'm Ella Shiratsky. We also have Sarah Hu here, a co-instructor who's potentially going to take over at some point because I'm not doing so hot today. But let's give it a go. So this is our lesson 5. And today we're going to start plotting stuff because that's what we're here for, right? To make beautiful plots for our papers. So let me share my screen. All right, can you see the RStudio Cloud? Yes, no, yes, no?
Yes.
Okay.
Hey, Ella, you can also X out of the menu on the left side.
Sorry?
The RStudio Cloud logo at the
Oh,
top.
gotcha.
Yeah.
This, all right. Cool. Yeah. Do you guys need me to zoom in further to make the font bigger, or is it good as is?
I think it's okay. You can also do the you have to always apply the global option for soft wrap.
How do you do that?
From tools.
Sorry that I don't know how to do this stuff.
It's okay.
Tools,
It's a second
tools, I
from
see
last
tools.
to global options at the bottom.
Right,
and then go to
it's
under code on the left.
Soft wrap, yes. Okay. Better? All right, cool. So we're going to need 2 packages for today's lesson. So you can, if you haven't installed them yet, you're going to have a little error message up here on the top of the script window that's going to say you need to install the packages. So either click on it or just execute this line. And while it's running, I'm going to start going over what we're going to do. So once again, I'm going to work with the IRIS database, which we worked with before when we were talking about data frames. So let's just load it and then see what it looks like. So as a reminder, we have all sorts of numeric parameters and then different species of iris. So I'm going to start by showing you how to plot with base R. And we're going to talk about a lot of graphical parameters. And today we're only going to cover XY scatter. Oops, sorry. But a lot of these graphical parameters will apply to any sort of plot that you make. So the simplest way to plot is just use the function plot and then give it your x-axis, what you want on your x-axis, what you want on your y-axis, and execute that, and here's your plot. So this is, I just picked random parameters, but we're looking at sepal length as a function of petal length. And we have these ugly circles with all of our time points. We're going to start with defining our labels, our axis labels, and a title for the plot. So as default, the title is going to be just a column name, but we can set it with these parameters here, xlab or xlabel and ylabel. And then main is going to be the title for the entire figure. So let's see what happens when we do that. All right. I also defined 2 other parameters here. Is I changed the color of our points to purple. And then I defined PCH. So PCH is the shape of your data points. If you remember in the previous plot, which we can view if we just click on the back arrow here, we had these circles. Now we have pluses. I just picked this at random. There are a lot of shapes that you can choose. I think there's 22 or 24 of them. You can just Google RPCH to see all of the shape options. I think the most commonly used one is 20. See if I'm right. Yeah. So these are just small full circles. Okay. Questions so far? All right. One of the most common things that you do with your plots is you want to give each series. So in this case, I'm going to use the species of iris as as a series, just like you would in Excel, and you can give it a different color. So each species is going to have a dots in different color. The way to do that, we have all of our previous parameters is the color is going to be defined by the species column in the table. And this is just going to be, these are just going to be default colors chosen by R. So this is what happens when you do that. You get this really ugly color scheme. And we're going to talk a little later about how to change it. But you can already see that there is a difference between the species just by the colors. Now, the most reasonable thing to do next is to add a legend. And you do that with a function legend. Top left is where you're going to put it. So it's going to appear on the top left corner of your figure. Legend is what's the text, what are the labels that are going to show up in the legend. And those are going to be the different species. The color is just going to be those first three default colors, so black, red, and green. And again, we'll talk about this later, how to change that. CEX is actually the size of the text. So by default, the default size of the text is 1. If I set it as 0.8, that means I'm making it a little smaller. If I wanted to make it bigger, I would say, let's say 1.5 or 2 or 3, and you can experiment with that. I encourage you to experiment with that so you can see what it does. So let's start by, let's add our legend. Here it is. And it got added up here. So other parameters that you can have here is, let's say you can have bottom right. I think for center, you'd have bottom center. We have something in the chat going on. Let's see. How can you get rid of the legend? Well, if you don't ask for it, it's not going to be there. So, you can just replot and then only set the legend that you want. So,
can I ask a follow-up question?
Yeah.
So base R, you start a plot and then you just keep adding on top of it.
Right.
But you always start with plot.
Yes.
Okay.
Unless, well, there are more advanced options, but if you wanted to save it, for example, as a PDF, then you'd start by defining a PDF and then you'd write plot. Or we're going to talk later about adding margins. You would first define your margins and then plot. But yes, plot is always going to be your first function. And then once you plot, if you want to add more series on top of that, you can use a function called points. We're not going to cover it today, but please Google it. It works exactly the same way as plot. And it's just going to add on top of what you've already plotted. Okay, so let's talk a little bit about the color scheme. Here I'm going to use a package called R Color Brewer, which is really popular. And it just lets you pick all sorts of color. It has built-in color schemes, including color schemes that are fit for colorblind people. So I highly recommend taking a look at their color schemes. And sorry, we're just going to see it in a minute, but I'm going to hit Display Brewer All, and that's just going to show us all of their color scheme. Of course, you can't see anything, but I'm going to hit Zoom. Can you see the zoom?
No, maybe you might be able to collapse the environment panel up at the
collapse this one. Yeah, I don't know how helpful that is. But if you zoom on your computer, then you can see the names of the color schemes clearly. Yeah. Okay, so those were the color schemes. And I'm going to work with a color scheme called Dark 2, which is somewhere here. I like those pastel colors. But pick whatever you want. Okay, so now I'm going to do the same thing. Sorry, so I'm going to define my own color palette. So instead of using the R default palette, which is going to be, which is going to start with black, red, and green, which is what we used before. Now we're going to define a different default palette by using this function palette. And we're going to use our color brewer and to create a color brewer palette using the dark 2 color scheme, and we're going to pick the first 3 colors from that. So now, and the reason I'm using 3 colors is because I have 3 series here, but if you have more, then just increase that number. Okay, I thought there was another something in the chat, but
I can look at it too.
okay, all right. So let's define our new palette. Oops. Okay, so now when I plot, it's going to default to this color palette. And there we go. Now we've picked the first 3 colors from dark 2. And it still looks pretty ugly, I think, but maybe slightly better. And again, when we add the legend, it's just going to default to these 3 colors. So that's how you use our color brewer. But you don't have to if you don't want to. You can pick your own colors. You can set them. If you've ever used RGB, hexadecimal color descriptions, you can just choose whatever you want. You can also, there are some color names that are built into R, but not a lot of them. So really you can define whatever color you want. And there are websites where you can just look at this like color wheel and then point at the color that you like, and it's going to tell you the color code for it. So I'm just going to pick these 3 colors here as my default palette. Plot it again. And now we have different colors. I actually created these colors using this website, Color Calculator. And what it does is it lets you pick how many colors you want and how different do you want them to be from each other. And then it gives you the colors that create the best contrast based on the first color that you choose. So that's just what I did here. This is how I got these codes. And again, you can add the legend on top of that, and voila, we have a slightly better figure. Yes.
One question about setting that palette and having like a middle set of colors in the chat. There's one question.
Sorry, let me see. What is a middle set of colors?
Is that, maybe that has to do with the total number, like, so you did n equals 3.
Here?
So yeah, so like the dark 2, like does it automatically just find, like if you have n equals 3, it's automatically finding the 3 that have the most contrast in the dark 2 color palette?
No, it's just going to pick the first 3.
Oh, okay. All right. Hopefully that answered the question.
Yeah. Okay. All right, so we were here and we created this figure with self-defined colors. Remember, whenever you're creating a figure, red and green is the worst possible combination that you can pick. Please don't use that, or orange and green, or anything like that. It cannot be seen by colorblind people. So if you insist on having green, then instead of red, you can use fuchsia, which is like hot pink, and that actually should work. Okay, so what if we want to change the size of the points? If we have, for example, very few points and we want to make them bigger, or if we have a lot of them and we want to make them smaller, we can use, once again, this parameter, CEX, to make the points smaller. So in this case, I picked 0.8. If I picked 2, for example, it's going to make them bigger. Boom, now we can't see anything. If I went back to 1, it would go to the default, which is this. And then in the legend itself, we can also edit this parameter. So if I want it in 0.8, it's going to show small points here, but if I did this, plot it again, add the legend again, boom, everything is now huge and you can't see your figure at all. Super helpful. One of the most common things that you'd want to do with your legend is actually put it outside of your figure. And in order to do that, you need to do 2 things. One is to create margins around the figure. And the other is telling R that it can actually plot stuff outside of the figure. So to define margins, we're going to use this extremely useful function called par. So let's just look at par, for example. I'm going to write $par in my console. And this is all the stuff that you can do with par. I highly encourage you to scroll through this list. It can change a huge list of parameters. So if we go down here to graphical parameters, you have a list of a few dozens of parameters. We're going to look at some of them today, but just pick your favorite ones. Par would be how you would create a multi-panel figure, for example, because you can divide your panel into rows and columns. You can add backgrounds, you can change the font. There are a million things that you can do with par. Par is your friend. In this case, we're just going to use it to define margins. So if we go to mar here, there it is. What mar does is it takes a numerical vector that's going to define the margins from the bottom, left, top, and right of the figure. And this is the default. So I am making all of the margins a little bigger, but mainly I'm adding a lot to the right, and that's where I'm going to put my legend, hopefully. So first I'm going to hit par, and it's not going to do anything because all I did is defined a margin. The next thing is I'm going to set par to allow plotting outside of the figure with this parameter XPD. So XPD by default is false, which is why the legend kept being put inside the figure. We're going to set it to true. Now we're going to plot. And notice that I have this huge margin to the right. And I'm going to add my legend. And this time, instead of saying top left or top right, because these are all relative to the figure itself, I'm just going to give it an X and Y position of where I want it to be in my entire sheet, or I forget what it's called in Illustrator. But and you can experiment with those numbers to put the legend wherever you want. So there it is. I managed to put it sort of close to the top of the figure and to the right of it. Questions so far? So once again, par is your friend. Please go through it. Find your favorite graphical parameter that you want to set. And this is going to be your first stop in every question about how do I make my figure do something. It's usually, the answer is usually going to be par. Okay. All right, so let's go into adding trend lines, which is also really useful. For this part, I am going to set par to be XPD to be false because I don't want my trend line to be drawn outside of the figure. So that's the first thing that I did. And now I'm going to calculate the trend line. So first of all, I'm going to calculate a trend line for all of the points in my figure. And I'm going to do this using a linear model function, LM, linear model. I'm going to give it my X, my Y, and then tilde X. So this is called your function. And it's always, in a linear model, always going to be structured as Y tilde X. So this is going to calculate actually the equation, the Y equals AX plus B, or your intercept and your slope. All right, so let's look at those numbers that we got. This is what we called. And then here are the coefficients that were calculated. This is our intercept and our slope. And we also get a p-value and an adjusted R-square, which is not bad, but what we really want to do is also plot this. So I'm going to use this function coef, or coefficients, of this fit, of this linear model, just to get the slope and the intercept, and save them into a variable. And now I'm going to draw a line that's going to take these coefficients as a parameter. So the function is called AB line. That just draws a straight line. Here I'm giving it the coefficients, so the slope and the intercept. I decided to color it blue, and then LWD means line width. And I set it to 2, but play with it, try stuff. So here's what happens when I add my trend line. And I have made my plots even uglier than it was before, and I think I deserve some applause for that. So just to show you what else you can do with AB line, thank you. I'd like to thank the Academy and my family. Okay, so 2 other things that you can do with AB line that are really useful is you can use it to draw a vertical line or a horizontal line. And that's really useful when you want to separate parts of your figure for some reason, or you want to point out a specific value. So if instead of giving it coefficients or a slope and intercept, you just use this parameter V, that's going to draw a vertical line at x equals 2.2. It's going to color it gray and set the line width at 3, just to show you what that looks like. Boom, we have vertical line. We can do the same thing to draw a horizontal line. And now our figure is officially probably the ugliest ever created. Congratulations. So this is all we're going to go over in plotting in base R. So if you have questions about plotting in base R, now is the time to ask them, because what we're going to do next is switch over to Ggplot and see how to do all of these things in a much easier manner in Ggplot. Let's see. Can you save the figure to a variable? Yes, you can. If you also want to save the figure just to your computer, there's a button called export here. So you can save as an image or you can save as a PDF. You copy to the clipboard. I highly recommend saving as PDF. It's going to save it as a vector PDF. So that's high quality. You know, if you want to, if for some reason you wanted to use this extremely ugly figure in your paper, then you would export it as PDF, and that would be high quality enough to submit to a journal.
What about like an R variable?
Yeah, so you mean like
you can you add, like, set that equal to X and then
like this?
Yeah, you can do that, right? And you can add on.
Apparently you can.
Well, if you type P,
but I'm not sure what it's gonna. I'm actually not sure that this is useful in any way. I know what you mean. So in tidyverse,
yeah. If you type P again, like by itself, that would be a way to just, oh, maybe it doesn't work.
No.
No. Okay. I didn't know that.
Yeah, me neither. This is how we discover things. This is
Can I-
how
can-
anything.
I have a thing.
Yeah.
So functions in R have outputs, so they return a thing, and they have what are called side effects. And the plotting functions, so in Ggplot, your plotting functions, their output, is basically the plot. Whereas in base R, the plotting function's output is usually something silly like the number 0, or in this case, null. But then the side effect of it is that it makes the plot. So the plotting functions in base R, basically you're calling them for their side effects. Other functions will have like their output is what you care about, and then the side effect is like a warning message or something that tells you about what the status of the output is, or the progress is for that function or something.
Right. For example, if I was running the linear model without saving it into a variable, then it would just print this output into the console, which is only part of the parameters that you got before, right? Before that, we also had an R square and a p-value, which we can't see now. Cool. Thank you for that, Jacob. Okay. Let's do all of this in Ggplot now. So I'm going to load. Oh, there's something else. What about exporting an image as a defined file format and image size? So yes, let's say you wanted to. So I've actually done this before when I was creating dozens and dozens of plots from like a data frame. And I don't want them to all show up in my plots window and then I'd have to export them one by one. I just want them to be saved as I'm looping through the table and creating those plots. I just want them to be saved into a file. So there's a function called, for example, I saved them as a PDF, but there's also JPEG and I think other formats. So I'm just going to plot $PDF in console. So all you would do is you would call PDF. You would give it a name, and then you can set all these other parameters. And then you would plot, and it would be plotted into the PDF. And then the one last thing that you need to remember if you do that is when you're done, you want to close the device with, sorry, device off. So it closes the PDF and saves it. Otherwise, it's never actually, it's only going to save the last thing that you do. Yeah?
Yeah, can I add, and then that has the width and height you can define. So then you can always make the plot with the same dimensions. And I actually use the same command, but I actually use vector graphics. And so it saves to an SVG file as well.
Oh, cool.
So instead of PDF, it's just SVG. And then there's a couple other options in there. It's $SVG.
Oh, gotcha. Cool. That's good to know. Yeah, that's really useful. Okay, are we ready for Ggplot? Is this our first introduction to Ggplot? I think it is, right?
I think so, yeah.
Okay. Oh, maybe there's something else. Okay, cool. So welcome to the world of Ggplot, which is so much, once you get used to it, it's so much easier than plotting with base R. We have worked a little bit with tidyverse before, and the syntax of Ggplot is actually pretty similar. So the nice thing about Ggplot, as Sarah already mentioned before, is that you can save your plot into a variable, and then instead of writing this whole thing again and again and again, you can just add to it with a plus sign. So the first thing that I'm going to do is I am going to plot into a variable. So it's going to save my plot into P. And the way to do this is the function is Ggplot. I'm telling it that the data set I'm using is iris. And then we have aesthetic parameters set by AES, and you have to set this. These are the most basic parameters that you'll set. So you give it a Y and an X, and you just have to write the names of the columns. You can, I'm not sure if you can use numbers, the numbers of the columns. I'm pretty sure that you can, but anyway, this is super friendly. So once we've done that, if I now type P, it's going to do absolutely nothing. Great, because I haven't actually added any data points yet. So if I just added all the data points with the function geom or geometric point, then this would be our basic, the first plot that we saw with base R, right? What if we wanted every species to have a different color? We would set the parameter color, which by the way can be spelled without the U. It's a personal preference, but it takes both American and correct spelling. So to set the color to change by the species, you have to give it the column name species, but you have to turn it into a factor, which is a slightly different type of variable that just recognizes that there are 3 different species here, because it doesn't really know how to create color from a text value. Okay, let's see what happens when I do this. So these are the first default colors in Ggplot. And the other thing that you can see is that it already plots the legend outside of your figure, which is really convenient. So you don't have to worry about doing that. If you don't like these colors and you want to set your favorite colors, you can add again with a plus sign. So as you see, we keep adding on top of what we did before. Now we're going to add a, sorry, yeah?
Yeah, one quick question about the factor part.
Yes.
If you look at the structure of iris, what is the species column?
Right, let's do that. So, oh, I see, it's already a factor.
So you actually don't need it, right? Like if you take it out.
Let's see what happens if I actually don't do that. Yep, it works. Good point. Thank you.
Yeah, and just to like, I think I've had to use factor in line like that when I had like a time series and I had like things were labeled 1 through 24 and
Right.
then needed to change the numbers to factors, right? You probably as well, yeah.
Yeah, or if you have different sites and you want to color by site, then it's not going to know what site 1, site 2, site 3 mean if it's a character column.
Try it with a character vector column. I think it'll work for that too.
I'm just looking for like distinct things.
You could for instance do instead of factor, you could do I think you could just do as that character or as, right? And then species. Try that.
Oh, well, I'm learning. I didn't think that would work, but okay, cool. So actually, okay.
But you could do like as factor sepal dot width, for instance, and then that would be different from if you just did sepal width, it would like do a nice color scale. Whereas if you did as factor sepal width, it would do every discrete sepal width as a different color.
Okay, let's try that. Actually. So now we do need to change this into factor.
We'll do it once without.
Okay, fine. Let's just do this part. Huh,
so now it's a nice spectrum, but if we as factor it, then every different sepal width, discrete sepal width will be its own special color. And so it'll look a lot different. It won't look better, but it'll look different.
Okay, let's try that.
Ta-da.
Charming.
Sometimes that's useful. Not in this case, but sometimes that's useful.
Yeah. Well, I mean, if you wanted to see, no, I can't. Really can't think of it. You know what? I was just, so I'm writing a paper now, and our first figure has, so it's an XY scatter, but we also have a color legend, and then the colors are actually pretty well correlated to the x-axis. So to show, so when you look at the figure, then you would have a gradient of the colors just because of the correlation between the x-axis and the colors. So I guess it can be useful. Okay, so let me change this back to species for the sake of the next example, which is how we're setting our own favorite colors. So I'm going to use this function scale color manual, which means I can tell it the codes of the colors that I want to use. Let's see what that does. Aha, this is my favorite color scheme that I use a lot. And it's not as ugly. I think it's not as ugly, but feel free to disagree. If we want to use our color brewer like we did before, it's actually built into Ggplot. So instead of scale color manual, I'm sorry, why does this alternate text keep showing up? We would use a function called scale color brewer, or scale color brewer, and then just tell it which palette we want to use. And boom, we've just recreated our color brewer plot from before. All right, so you can also change the size of the points, which we did earlier with CEX in base R. Here it's just going to be called size. Now it's going to go into our geometric points function, where we set the color for our points, but size is not going to go inside the aesthetic parameters, okay? Just make sure that you close these brackets before size. Otherwise, size is going to be assigned also by species or by point, which doesn't really make any sense. We want all of our points to be size 2, so we write it here. And boom, our points are bigger now. I can set this to 5 to see what happens. And once again, this goes in the Hall of Fame of ugly plots. So I'm actually teaching you how to make the world's ugly plots today in the hopes that you improve them. Okay. So the size of the points can also depend on a variable, like in a bubble chart. And then to do that, you would actually set the size to be inside the aesthetic parameters instead of outside, because now we want each point the size of each point to be determined by, let's say, the petal width. So when we do that, it looks like, so we've added information here, right? So it looks like the setosa actually has much smaller petals compared to the other species. All right, so questions? No. Okay. The one thing that I haven't worked on yet here is the background and the grid lines. So this is the default, what's called scheme of Ggplot. There are a lot of other schemes that you can choose, so it would look different. So let's just start going over them to see what happens. Oh, sorry, not scheme, theme. So this is the default theme. There's a theme called classic. So if you go question mark on the console window, theme, and then underscore, there is a list of themes that you can choose from. So I'm going to show you a few of them, but feel free to experiment. let's try classic. So same plot, but theme classic. Now we just have the axis and no grid lines. For the next one, I'm going to try a different theme called theme dark, but I'm also going to change the shape of the points, which we did before with PCH, if you remember. Now we're just going to change it with shape. So, boom. Now we have the dark theme and a weird grid shape data points. What if I change this to 20, like in PCH 20? I'm just curious to see if it's the same. Yeah. So this is really the same parameter. It's just called shape this time. Okay. What if you wanted to change the points depending on the species? So have just a different shape for each one. Once again, inside the aesthetic parameters, you would set the shape to be equal to species. So before that, we had the shape outside of the aesthetic parameters so that all of our points look the same. Now it's inside, so it's going to change by the value of species for each of the points. Okay. I hope it doesn't look as distorted on your screens. But yeah, anyway, beautiful, beautiful figure. If you had another grouping variable, so this would actually mean something, because in this case, the shape and the color actually convey the same information. But what if we had a different grouping variable in addition to species, and then the shapes would actually have some sort of additional meaning? So I'm just going to create a new table called temp, and I'm going to create a new variable in it called new group. And then I'm just going to randomly assign it 1, 2, or 3. So it's not going to be correlated to the species. And now I'm going to plot this table instead of iris and create the same figure. All right, so I recommend that you zoom in your computer to see what this did, but now in each of our groups we have different shapes, and the shapes would mean whatever number was assigned in this random variable, but hopefully your variable will actually have some kind of meaning to it. All right, axis labels are set by just adding, once again, parameters xlab and ylab. And then instead of main, in Ggplot, the title is called ggtitle. So once we add all of these parameters, now we have the proper axis labels, and we get our title right here. Or you could set all 3 of these with one function called labs or labels. And you would tell it that this is the title, this is the x-axis and the y-axis. And then you can do everything over again and it looks exactly the same, but with less rows in it. To change the legend, title, and labels, you would use scale color manual. Tell it what you want your values, what you want your colors to be, what you want the values in them. Column are they based on? You know what, let's just run this and see what it does. Okay. So what I did here is I picked which name is going to go with which value of the species column is going to go with which color. And then I also told it which label it's going to have. So notice that in the column, Setosa is not capitalized, but here the legend label is capitalized. I can also call it George. No, you know what? I'm going to call it Jacob Sarah, and Ella. And now we have a publishable figure. Okay, so we can also add a trend line in Ggplot, and it's built in, so it also calculates the model by itself. We're going to do that with a function called geom_smooth. We're going to give it a method of linear model to tell it to create a linear trend line, and then we don't want any error bars in this case, so let's just, here's our line. Okay. If we wanted to add, let's say, a 95% confidence interval to this line, then we would actually set standard error to be true. And if I'm not mistaken, 95% is the default, so that's all I'm doing. Right, so now if you can see, we have a confidence interval around the line. If we wanted a 90% confidence interval, we would do everything the same, but now we would set level to 0.09 for a 90% interval. If you want 80%, it would be 0.8, etc. So there we go, 90% interval. And I think the last thing that I'm going to do is, it actually makes sense to create a trend line per series here, or per species. So I'm going to start the plot over. And I'm going to add, sorry, I'm so tired. Did I actually do this? Yes, I did. Okay. Sorry, I lost my train of thought. And I don't remember how I made it plot by species.
You mean the factoring part component, or?
Yeah, the trend line. What made them separate?
Oh, usually there's like a grouping or something.
I mean, obviously I did it somehow. Maybe just
pull
like,
up the help menu. Pull up the help menu for geom_smooth.
I think I did it. Where did I define P before this? Right, so the way I did this is here by grouping. Here I'm grouping by species. And then it automatically will group everything else you do by species. So in the aesthetical parameters of the original Ggplot function, I have my Y, I have my X, and have a grouping variable. So, and I also set the color to be by species, but it's also going to automatically just group everything by species. Yep, and this time I set the confidence interval to be 99%. Okay, that's it. That's all I've got. Do we have questions? I hope I wasn't really confusing towards the end. Ggplot is really useful, and once you start playing with it, you'll get it. You'll get the hang of it so quickly. It's super friendly, and it's really hard to make mistakes with it. So worst case, it's not going to look exactly like you wanted it to look, but you know, it's not going to throw random errors at you like a lot of other R functions. Okay.
Yeah, I think one thing we'll do moving forward is when we did intro to data wrangling, we asked the Slack group if what they would want to wrangle with respect to data. And so maybe we'll do the same thing of like what else they would want to learn how to make plots with or for.
Right, so just like in base R, where the same graphical parameters would apply to an XY scatter or a line or a bar graph or box plots or anything, it's the same in Ggplot. All of the stuff that I taught you is going to apply for any other type of plot that isn't an XY scatter. So I mainly use Ggplot to make box plots because base R is not super friendly for that. I'm kind of old fashioned, so I'm used to base R, but I recommend from the bottom of my heart that you just get used to Ggplot and do everything that you can in Ggplot because it's just so much more versatile and friendly. Okay. Cool. So if we don't have any questions, thank you for joining us. And thanks to the instructors who supported the chat. And we'll see you in the next lesson.
Hello, I have a quick question.
Oh, yeah.
Sometimes I try to, sometimes I try to put too much information in a plot. Say by like on the x-axis or the y-axis, and I have issues exporting the file because sometimes like when I try to export it, it only shows part of or the window that the plotting screen, the plotting window that's like constraints to that. So how would you export it if it was a larger plot? If you know what I mean. So.
I don't think I've ever had this issue.
I think that's when I used the PDF or SVG option that Ella showed, where you set the width and height.
Right. Also, when you export from here, you can pick the size of the plot that you want to create.
Yeah, there's the same option when you use export image instead of PDF, in case you need to make another image for some reason.
Oh, okay. Okay.
And I would also recommend using the preview button down here. You can see what it's more or less going to look like.
Okay, thank you.
Sure. All right. I guess we'll see you next week.
Come to office hours.
Yes, come to office hours Friday at
1:30.
1:30 EDT.
Yeah, Eastern. Good point.
All right.
Thank you, Ella.
Bye.